The X13 motor requires high voltage power to operate the electronics and eventually operate the motor, and low voltage communication to turn on the motor and tell it what level to operate at. The nice thing I think about the X13 motor is that this connection block is the same on all three different voltage motors that we make. So no matter what X13 motor you're working on, this connection block will always be the same. On our 115 volt model, the L stands for line 1, the G is ground, and the N would be neutral. On our 230 volt model, the L is still line 1, G is still ground, but in this case, N would be your line 2. Now in both cases, the voltage input to the motor can be plus or minus 10%, and these motors will work on both 50 and 60 hertz power. It is also important to note that these are not dual voltage motors. One is built at 115 volts and one is built at 230. And on the new 460 volt, again, L stands for line 1, G would be for ground, and N would be line 2. Next is the communication inputs. On the X13, there's 5 communication inputs. They're often called speeds, but they're actually torque settings that can be programmed by the manufacturer. So the OEM manual will be needed for each appliance that uses X13 to know which taps are being used for heat, cool, fan, exactly what they're programmed for. Now these taps are also programmed for multi-state inputs, and what that means is you can turn on more than one tap at a time without damaging the motor. In other words, you can energize tap 1 and tap 2 at the same time. The motor will simply do whatever's stored in tap 2. You can turn on 1, 2, and 3, it'll do what's in 3, and so on and so forth. Now I should also mention that these taps are 24 volts. Almost all manufacturers to date are using 24 volts for communication. However, there is the option to use DC communication. So in 24 volts, for example, if tap 1 had a program in it, I would apply 24 volts to tap 1, and right above that tap, the motor would read that voltage back on common. So all of the taps 1 through 5 are going to reference the common tap, which is a low voltage tap that's in the upper portion of the plug. Here we see an example of an HVAC system with an X13 motor. This is a 115 volt system. It's got line 1 and neutral connected to the motor, and it has all 5 taps of the motor connected to the OEM circuit board. If you look at this at a quick glance, you might think, well, that looks really the same as a PSC motor, other than the line, ground, and neutral connections on the motor. But what you'll notice if you look at the schematic for the system or measure voltage is that the voltage going to taps 1 through 4 is 24 volts, which is very different than a PSC motor. So let's look at an example of a package system using X13. This happens to be a gas and AC package system, and we notice that there is a heat and a cool tap sending voltage to the motor. However, we also notice that there's 3 of the taps on the motor that say no program. That's because the manufacturer does not have to program all 5 taps of the motor. So as I mentioned before, this connection block will always be the same. There's always the potential for 5 speeds or torque settings out of the X13 motor. However, the manufacturer only has to program the ones that the system that they're putting the motor in require. Being that this is a gas and AC only package system, it simply needs a heat speed and a cool speed for proper operation. Next, we see an example of an air handler application, which could be used on air conditioning or heat pump. And we again see that there are 3 taps programmed. Taps 1, 2, and 3 are programmed to work on 2-ton, 3-ton, or 4-ton systems. But taps 4 and 5 again have no program. This is very common for many X13 systems to have 1 or more taps that have no programs in them, especially when it's on such a specialty type system as a package system or an air handler. And finally, we see an example of a furnace application. We see that there are 2 heat taps and 3 cool taps. The 3 cool taps being for whatever tonnage of air conditioner you're going to connect to this furnace, in this case 2, 3, or 4 ton. And we also notice that all 5 taps are programmed. So there is the potential that all 5 taps will be programmed. There is also the potential that there may be only 1 or more taps programmed and some with no programs on them. Why is that important? Well, specifically if you were having an airflow problem and you wanted to move from a lower tap to a higher tap, you would need to know, one, if the next tap up had a program in it, and two, if the next tap up in numerical value on the face of the X13 motor was actually a higher airflow. The manufacturer does not have to program them higher in airflow by the numbers printed on the motor. They can program them any way they want to. So the OEM manual that comes with that appliance is really going to be quite important for working on X13 systems. So now that we know how the X13 can be programmed and what each one of the connections on the motor does, let's look at how the wires are connected to the motor. You'll notice from this picture that the high voltage L, G, and N terminals are actually smaller than the low voltage connections, the C and the 1 through 5. This was done on purpose so that a high voltage wire could not be put on a low voltage connection, which would be bad for the motor. Here we see a picture of the high voltage plug that we specify for the motor. This plug has a full blank that fills in the hole next to N, and the L, G, and N portions of the plug are smaller than the C and the blank portions. So there's really no way for this plug to be put in upside down, and there's no way for this plug to fit on the lower half of the motor in the 1 through 5 connection. It assures that the connections will always be done the right way. Now we see a picture of the low voltage connector, and it also has been designed so that it can only go in one way. On the lower portion of the connector, there's a large lip on the connector so that if you turned it around, it would run into the wires that are connected into C, L, G, and N. Therefore, this can only be plugged in where the terminal 1 wire goes into terminal 1, and so on and so forth. Now, with all that said, the manufacturer does not have to use these plugs, and some may not. Here we see a picture of a package system that is gas only. Therefore, there's only one tap programmed and no need to use any plugs or connectors. Simply use what we call flying leads to each one of the places on the motor that power and communication are required. Since only one tap is programmed and none of those leads will ever need to be moved, this is a perfectly acceptable way to connect the motor. So in the field, you may see an X13 with 2 plugs on it. You may see a high voltage plug with loose wires on the bottom, or you may see loose wires going to the entire motor. It's entirely up to the manufacturer, and there's no right or wrong way to do it. So what we've learned so far is that the X13 is versatile, but it's also very simple to work on. We will need the OEM manuals that go with the appliance that an X13 is used in so that we know what tap to use for the right airflow for each heating, cooling, and fan demand in the system. X13 is ECM technology made easy.